Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at transforming functions. Now it's going to be quite a quick lesson because we're just going to have a look at this with one example. Transforming functions is kind of a mix of stretching and translating, okay? But what we're going to do in this example is just have a look at how different points and intersections and turning points differ from different translations and from different stretches, okay? So what we have is we have a diagram that shows the sketch of a curve f of x, okay? And it's actually y is equal to f of x, okay? Don't know what the function is, I just know that it passes through, like it says, the point 0, or the origin, which is at 0, 0. It passes through the point A, here, which is at 1, 4, and it passes through B, which is at 3, 1. Okay, they all lie on the curve, so the curve passes through those points. We want to sketch the following, stating any turning points and intersections, okay? Or interceptions as well with the y or x axis. Okay, so we've got four parts of the question. We've got part A, which is sketching f of x plus 1, B, sketching f of x minus 1, C, which is sketching f of x minus 4, and then D, which is sketching 2y is equal to f of x. Okay, so pause and have a go if you want to, and then for the rest of this video, I'll work through the answer. Okay, let's have a look at part A. So all we want to do is sketch f of x plus 1. Now what I'm going to do is, I'm just going to steal this graph a little bit. We'll steal it and we will put it down here. Now it passed through the origin, didn't it? So it's going to look something like that, okay? And I'm just going to get rid of that point there. Now, that was the original graph. In the previous videos, we've had a look at how we can translate graphs. And I can see here, I've got a plus 1 inside my bracket with the x. So what that means is, and have a look on a previous video if you're unsure, we're going to move this graph by the vector minus 1, 0. We're going to do nothing to the y direction, so there's going to be no vertical movement, it's all going to be horizontal, and we're going to move it by the opposite sign to the constant that's inside the bracket, so minus 1. Okay, so if I take the whole of the graph, I'm going to move it by minus 1, and it's going to look something like that. Okay, now it's useful actually if I just take these points. So let me draw those points on for you actually so you can see. This point here was 1, 4 and this point here was 3, 1. Okay, if I move this graph like that, I'm moving it 1 basically to the left. So we have the origin as well here. The origin is going to kind of become the point 1, 0. And this A, which is 1, 4, we're moving the x in the x direction minus 1 or 1 to the left. So we're actually going to be intersecting the y-axis, aren't we? It's going to be something like that, okay? Where, and I'll draw it on black, this point will be 0, 4, because this A started off as 1 and we've moved 1 in the x direction, the negative x direction, so we've kind of taken that 1 back off, we're now on the y-axis. And then if we think here, this point will be, well, we were at the x value of 3, we've gone 1 to the negative x direction, so it's going to be 2, 1. Okay, and that is the graph y is f of x plus 1. So it's always useful to consider how points move. And this point here will be minus 1, 0 as well, because that point came from the origin moving minus 1 or 1 to the left. So we're now at minus 1, 0. Okay, so that is a really easy way to sketch a graph. I don't know about the equation of the graph, I just know 3 points on the graph. It looks something like a transformed cubic, stretched a little bit, it's got different turning points, it's got 1 there and 1 there. But that's the only, as I say that, I've just thought of this, those are the only turning points I can see. So actually, the graph could maybe continue something like this and do that. And I'm not seeing that part of the graph, okay? And it could come back down like that, okay? I have no idea what the graph does. So just by considering this little bit of the graph, I could say it's a cubic because it's got 2 turning points. But we don't know any other turning points sort of outside of that region. Okay, so anyway, that's how we can look at part A by considering those 3 points, A, B, and then the origin. I'm going to do the exact same thing here and consider those 3 points to sketch this graph. So B says y is equal to f of x minus 1. We had a plus 1 here, so we moved by minus 1, 0, or that vector. We've got a minus 1 here, so we're going to move by the vector 1, 0, the opposite sign, so it's going to become a positive 1 now. Okay, so again, I'm just going to steal the graph. The original graph looked like that, okay, and it might actually be quite useful if I move my y-axis over a little bit there, so I can move this graph. There we go. That's how the original graph looked. It crossed through the origin, and we have the 2 turning points there. This time what we want to do is move it 1 to the right in the horizontal direction. There's no vertical translation, it's just horizontal because we've just got the minus 1 inside the bracket. Okay, if for example we had maybe a plus 2 here, then yes, there would be horizontal and vertical, but we don't have that plus 2, so let's get rid of it. Okay, so that's what we have there. And if I move it 1 to the right, it's going to look something like that. Now, it's not perfect as long as I get the correct scaling, okay? This point there was the origin, but it's been the origin moved 1 to the right, so it's now going to be the point 1, 0. This was point A, which is 1, 4. Okay, but we've moved that point now 1 to the right, so it's going to become 2, 4. Okay, our x values become 1 larger. And this point here was B, which was 3, 1, but the x values become 1 larger. So it's now going to become, and I'll just write it here, it's now going to become 4, 1. Okay, and then I can write that on there, that's the graph of y is f of x minus 1. Okay, so that is part B. Part C, we had f of x minus 4. So this time we can see the minus 4 is not inside the bracket. We've got the function, we're just doing that function and minusing 4 from it. Okay, so when it's outside the bracket here, this constant, that means it is a vertical translation, and we looked at that in a previous video. It's a minus, so we're going to be going down. We don't do the opposite sign here. If it's a minus for a vertical translation, we go in the negative direction. We're going to move all of our points down by 4. So let me take the original graph here. I'll just get that graph. I'll bring it down here. It's always useful to consider the original graph, consider the points on it and see what happens. So it looks like that. I'll move my y-axis over again. So that is what our original graph looks like. We're going to move it down by 4. So actually it might be quite useful. Just do a little bit of rearranging here. That looks a little bit better. Let's move the graph down by 4 in a vertical direction. So it's going to go down by 4 to look something like that, actually. Considering the points that we had, if I duplicate all of that, okay, these were the 3 points. This was the original graph, okay, we can see that there, okay, and I had this point, which was B, that was 3, 1, okay. Considering those points, I am going to minus 4 from all of those. We started with a y value of 4, so moving that point down by 4 means, well, we're going to take 4 from this y value to give us 0. So that point is going to be 1, 0. The x value is not going to change. We can see that's exactly the same because it's just a vertical translation, but my x value will change and it'll become 4 less. So we're now going to be on the x-axis. Okay, and this point here, b, was 3, 1. I'm going to take 4 from my y value. The x value is going to stay exactly the same, but my y value is going to become minus 3 because we were at 1. We're minusing 4 from it in a vertical direction, so minus 4 takes us to the y value of minus 3. Okay, and we were at the origin here. I'll write that on. That was the origin. So now minusing 4 from that in a vertical direction will be the point 0 minus 4. And then I can get rid of all of these points here. That was the original graph. So just considering the 3 original points that we knew, the origin and A and B, we've now sketched what the graph looks like for f of x minus 4. Okay, and then D is not a translation, it's a stretch, and we had a look at stretches in the previous video. It's written slightly differently here. We've got 2 times y is equal to f of x. I want y equals something, so I'm going to divide both sides by 2. So that tells me y must be a half f of x, okay? And then we can see it's a stretch. Now, it's a stretch in what direction? In the horizontal direction or in the vertical direction? Well, we can see here what we've got is our constant outside. So all of our y values, because we've got half of the function now is our values for y, all of our y values are going to become a half less, if you like. They're all going to be multiplied by half. They're all going to be divided by 2. Okay, so I'm just looking at the sketch here, and we can see it's going to have a scale factor of a half because that's the half out the front. If it was with the x inside the bracket, we'd do the reciprocal, but it's not here because it is a stretch in the y direction. Okay, so really what I can do here is actually take this original graph. If I duplicate that, I can take that original graph and really keep it like that, okay? And if I just move the y-axis over and move that, there we go. That's what our original graph looked like. Now, because I'm not comparing it with the original graph, I can keep that as my stretched graph, if you like, as long as I've got the points correct. That's the point of this example. We're looking at how points change, okay? Now, the origin is going to stay exactly how it was because 0, 0, multiplying that by a half just stays as 0, 0, okay? We've got a half of the function now. So my y value will just half, and it's 0, so it's still going to be 0, okay? Looking, though, at my other points, A, what did A start off as? A was 1, 4, okay? So I'll write that here. A was 1, 4. It is a vertical stretch, so all of my horizontal points are going to stay exactly the same. So I can really write that on already as 1, okay? Now, it was a scale factor of a half, so all of my y values are just going to be divided by 2. So instead of this, which was originally 1, 4, it's now going to be the point 1, 2. Okay, and then this point here, we've got, well, what was the original, I can't remember, the original x value was 3. That's going to stay exactly the same, but the y value is going to half. That y value is going to become 1 over 2, or a half, okay? And I can see that that's exactly correct, so I can write that on here. That's y is a half f of x. So that's what we mean when we stretch with a constant outside of the function, okay? This graph that I actually duplicated was exactly the same as the original graph. But we can see with a little bit of scaling on the points, we can see that actually it has been stretched, even though the shape of the graph looks the same. And that was the kind of point of this video. To translate and to stretch, it's really useful if we know some points on the graph. Then we can have the same shape, but just with different points depending on the translation or the stretch of the function.